Hi folks, this is activity TT60 in my CAD class. The purpose of these particular activities on finite elements is not to teach you finite element, but show you the steps in order to follow and get a very simple part analyzed. Okay, I'm not showing you, I'm not teaching you the assessment of the quality of the results that you get, but merely the process behind it. Okay. What we have here is this geometry that you see. It's made out of steel with default material properties in Catia, and the four top circles are clamped, and the top face, this rectangular face, is subjected to a pressure of 100 psi. Now, I also want to point out that in on the exam, on the final exam, I will give you problems of this type, but I will tell you to use as many planes of symmetry that are applicable. If you look at this problem, and if you don't use any planes of symmetry, which is the first thing that I'm going to do, and that is not to be uh, taken for granted on the final exam, most people might see a plane of symmetry this way and horizontally, vertically and horizontally. That's almost correct, not quite though. Because notice that if you take a plane of symmetry which is vertically down, for example, and at 45 degrees in a slanted direction, what you get is a rectangle, a right triangle, which is repeated 8 times around this uh, uh, axis coming towards you. So basically, 1/8 of the model is all you need to do. So after I do the problem without planar symmetry, I will come back and repeat that with planar symmetry taken into account. Okay, so let's go ahead here, start with the part file, and I'm going to call this thing TT60. Okay, immediately I'm going to put it in the folder that I have reserved for that. So File, Save Management, Save As. There's a folder here called Week 9 right there. And uh, yeah, I'll just put it there. Good. Now we're going to make it. My units are already changed, have already been changed, but let's double check that. So we go to Tools, Options, and notice that the length is inches. I don't have a force here, but if I did have a force, I've changed it to pound force, and pressure is over there, which right now is Pascal, Newton per meter square. I'm going to change that thing to PSI. If I can find this right there. Okay, good. So on the horizontal plane, I will sketch. Remember, first time that I'm going to do it is will not be using any planes of symmetry. So I'm going to make two rectangles, embedded rectangles within each other. Okay, let's dimension these things. So dimension this one is 10 inches. So is that vertical edge, that is 10. The side ones are 5 inches, is a 5. And there is a 5. Okay, exit and padded by 2 inches. Okay, good. On that top face, I will sketch a circle. We will clean it up in just a minute. So, for example, the dimension of that, the diameter of that circle, actually, if you read the problem statement, it says its diameter is 1 inch. And then I'm going to position it properly. So position it 1.5 from this each edge. So 1.5. and 1.5. From here to there, 1.5. Okay. And what I can do is I can uh, mirror this thing 4 times here, okay, and basically get the circle. So let me do that. That's one way of doing it. The other way is to make one of these paths and then mirror it in the part design, but you can also do it here. So you mirror, not symmetry, mirror, this mirror, yeah, that circle with respect to this, and repeat the process, mirror this guy with respect to that, and finally mirror that fellow with respect to this. And exit and pad it by 2 inches. Now remember, at some point later on, after I do this problem, I'm going to come back and basically cut these things, get rid of them, but not yet. Okay, so we're going to apply material on it. Here's the apply material. We're going to make it out of steel. Default properties. Good. And that's pretty much it as far as the model is concerned. So now I'm going to go to analysis and simulation, generative structure analysis. We are doing a static analysis. And let me change the rendering here. The reason it looks like that because we put material on it. So let me change that thing to without shading. Here's the rendering icon. Now this is a very large element uh, because I can mesh it, but you can see that it's going to look ugly. If you look at it, you see, look at the top of these things. Look at the basically these are mesh with elements which are highly distorted. So what I'm going to do instead, I'm going to change the mesh size. This piece, this is okay. That piece is okay. What is not okay is the stuff up here. So there are different ways of handling that thing. One is just make everything small, even down here. And the other one is just locally change these things. So let me actually go and do a local mesh refinement here. So when you look at the model manager right here, and you look at the second toolbar, and there's something called local mesh size. Before I can do anything, I have to put this mesh away because while it's staring at you, you cannot do things like this. You cannot apply loads. You cannot apply restraint. So I'm going to put the cursor, instead of deleting it, right click, deactivate. That means put it away. I don't want to see it because now I can select stuff. So let me do a local mesh. I'm going to select this and that and that and that. I put a number here. For example, you put down point. Right now, we can see that with that 0.3 that you have there, size is like this. Okay, so okay, that's fine. We're going to do it. And look at the mesh. Right click mesh. Oh, put the cursor there. Right click, activate it, and you see that it's a lot more civilized on these shafts. Okay, good. So deactivate it. All right. And now we're going to go and apply the restraints here. Where is the restraint? Remember, some of the important toolbars are model manager, but I just used to do local mesh size. And then there is a restraint, which is right here. Something is clamped or something is on a roller. And then there is loads. And then there is compute. And of course, at the end, when you get it, there's the results that you can look at, and it's under image. See if I can find it for you. Okay, in all likelihood, it doesn't show right now because I haven't run it yet. You can always ask for it. So you go to View, Toolbars, find the image. You want to see it right there. Okay, but there's nothing there right now, and that's why it was not showing because there's nothing to plot. All right, good. So these things I don't need. So here's a clamp icon on that top one, on this, and that, and that, and they're fixed. Then I have a pressure. Here's a pressure. on that entire top face in the down in 100 psi, right? 100 psi, and then we say, okay. Now notice that the way it shows the pressure is through this guy, this arrow. Let me hide these things so that you don't see it. So it's kind of unfortunate. It doesn't put the pressure like icon on these surfaces. It's right there. Okay. Now let me show you something. Let me double click on this. Let me double click on this pressure that I put in there. This is what I want, but I want to show you something. Double click on it. And instead of this face, also select that face. Notice that it does put this kind of a thing that resembles pressure. But anyway, that's not because this guy has a hollow middle. It just puts a single icon like that at the centroid, and that's why it looks ugly like this. Cancel that. The original was fine. That's pretty much it. So before I do anything, so you go File, Save Management. The analysis is not saved. The part you save, but not the analysis. Save as, and in that same folder, and I'll call this thing T60, right? TT60. And I want to remind you that on the final exam, you not only have to give us the part, but you also have to give us the analysis if you're doing a finite element calculation. Let's check that, make sure it is in that folder. My folder was right here. Where's this? Uh, and notice that the part is there, right there, TT60, and the analysis is there. Okay, very good. Exit. And the last thing is compute. All, make sure this all is on. Say okay, and then say okay, and it's going to be done. Now, you want to see the result? First of all, you want to see the shape of deflected shape. Double click. That makes sense, right? And you can see that there's a symmetry involved here. That's why we could have gotten away with only doing 1/8 of this. And if you want to look at the displacement right there, these are all downward arrows because they all go down. But if you don't want to see it in the form of arrow, so say average ISO and change the rendering to material shading. Looks like that. And see how symmetric it is? It should be, right? And if you want to see the stress right there, and obviously these are the most stressed parts, okay, the pieces. Now, it's very easy to generate good looking garbage. That is not assessing the validity of these things is not the purpose of what I'm doing in this course, which is a CAD course right now. If you're interested, you have to take a finite element course and we'll talk about it. Now, you just have to make sure that whatever you get here does not go below the or above the yield strength. Otherwise, the analysis would have been completely nonsense. Very easy to generate good looking, meaningless things, colors. Okay, so let me save this thing. But let's say that somebody said, you know what? I actually want to use symmetry here. So what I'm going to do is I'm going to close that. I'm going to go to my part. There's my part. And start cutting this thing so that I have only 1/8 of the model. What's the easiest way of doing this? Here's what I'm going to do. I'm going to go to the cut first of all, right here, split. See that? Split this whole shebang with that plane, and it doesn't matter which side you pick, and another split with that plane, doesn't matter which side. But I also want to cut it through this, through the 45-degree angle. So I'm going to create a plane through 3 points, 3 points. The points being, for example, this, and that. And now split with this fellow. So split with that fellow. Oops. What do I do? Yeah. That means take the other side. There. This is 1/8 of the model. That is all you need. The material is already on it because I used the part that was already material put on. So now we're going to go to generative structure analysis. There we are. You see? All right. And you know what? Before I do anything further, first of all, let me change the rendering here so it doesn't hurt your eyes. So we go to File, Save Management, this analysis, Save As. I'll call it TT61, TT60, but with symmetry. With symmetry. So you say okay and okay. All right. So let's see what we've got. We have this top is cloud. Don't leave these faces, which came because you made cuts, alone. Don't just let it sit there. These are on rollers now. Okay, these symmetry planes can only go up and down, cannot go sideways because they're called symmetry plane. And Catia does not call it roller, it calls it surface slider. Right where your clap is, there is a surface slider or roller. So this is on a roller. See that? And this is on the roller. Very frequently people forget to put rollers there, or they put it on the wrong spots. But anyway, you're doing this thing because you don't want to do that. You don't want to make a mistake. Anyway, let's save everything. Oh, the pressure. Let me apply the pressure here. Should I divide the pressure by 8 because the top is actually 1/8 of the original surface? The answer is no. Pressure you don't divide. Pressure is already have taken division by area into consideration. But if this, for example, top was under, let's hypothetically say, 1,000 pound force, not PSI, pound force, and you took only 1/8 of it, then you have to take that 1,000 and divide it by 8. Okay? But not pressure. You say, okay? And let's go do a quick save here and run. Oh, I forgot to do mesh refinement. Okay, cancel that. Don't run. I forgot to do local mesh refinement, so let's go ahead and do that. So remember where it was? In the second sub toolbar, you opened it up, and there was something called local mesh size. You select it, and you select that, and I'll use the same value, 0.3. I think I used 0.3, if I'm not mistaken, and then run it. That's fine. This is not an error. It's because you put that roller on it. And that's pretty much it. So here's the deflection. That doesn't surprise you. It should look like that. This vertical plane and the side plane should remain flat because that's what planar symmetry means. And if you animate it, it's what you expect. It goes down and then if you want to look at, for example, your displacement right there, change this thing to average ISO and then change the rendering to material shading. Now these things that I'm showing you, you cannot get them unless it's successfully ran. Okay, and if you want to look at the stress, one meter stress right there, and hopefully it's not going to be very much different from your analysis before local measurement, because before taking symmetry into account. One other comment is that notice that when I the original model and meshed it, the size of the mesh before I did the refinement was much bigger than this because Catia has an algorithm which looks at the size of the object and based on that comes up with the original mesh size. Okay, and here, because the size is only 1/8 of the original one, this thing actually is smaller than what you saw originally. And that's why when I did the local mesh size, 0.3, it doesn't show much smaller than this fellow. Anyway, that takes care of this activity. Please keep in mind that with these tools, engineering tools, if you're not careful, you can just generate color, which are totally meaningless. All right? Good luck.